Welcome to today's deep dive. We are exploring the hidden infrastructure behind those massive audiovisual setups. We're pulling from technical specs for the QSC QIO-ML24i audio expander and the Wolfpack fixed HDMI matrix switchers. And really, our mission today is to uncover that invisible architecture, making giant sports bars or live events work without just drowning in a chaotic mess of cables.
Right. I mean, think about walking into a huge venue on game day. You see dozens of screens, you hear perfect audio, but you don't see miles of wiring hanging from the ceiling, right?
Right.
Managing that isn't about hiding the wires. It's about fundamentally changing how signals get routed.
Okay, yeah, let's unpack this. Starting with the audio side, the QSC unit. So the specs say it crams 24 mic or line level inputs into a single 1RU space,
Yeah.
which, 1RU is just one rack unit, basically like a standard pizza box size slot.
Exactly. And historically, if you had 24 mics on a stage, you had to run 24 thick individual analog cables all the way back to some central processor room. But this QSC unit, it changed the game by acting as a localized drop box.
Oh, so it operates like a digital on-ramp, right? You place this box right next to the stage, run really short cables to it, and it immediately translates all that local street traffic into digital packets.
Yeah, and it merges them onto the high-speed digital highway, which in this case is the QSYS network, the overarching digital brain routing everything.
Right.
What's really fascinating is the efficiency. Once the audio is just data on a network, you can send it anywhere in the building over a single standard cable.
But wait, my first thought is putting everything onto one network creates a terrifying single point of failure. I mean, if the network drops during a live broadcast, you lose all 24 mics at once. I assume there's some sort of redundancy baked in.
Oh, absolutely. This gear is built for mission-critical environments. It's not a passive connection. The system is constantly pinging the hardware over the network, monitoring the health of the connection right down to microphone detection.
Oh, wow, so it knows instantly.
Exactly. If a fault occurs, it doesn't just crash. It automatically routes the data through a secondary backup pathway in, like seconds. The audience never even hears a drop.
Okay, makes sense. So we've solved the audio by converting it to IT data, but video data is exponentially heavier. How do you apply that clean architecture to, say, moving 16 different HD games to 16 screens without crashing the whole system?
Yeah, that requires some serious heavy lifting. And that is where our second source comes in, the Wolfpack fixed HDMI matrix switcher.
Right, and just to clarify for everyone, this is very different from a standard HDMI splitter. Like a splitter is basically a megaphone just shouting one video feed to every screen. This matrix acts more like a highly trained digital switchboard operator.
That's a great way to put it. It allows you to instantly route any specific input to any independent output in literally any combination.
And the scale is wild. The specs outline a 16 by 32 configuration, so 16 inputs to 32 outputs.
Yeah, but the real trick is how it covers the distance. Standard HDMI starts losing signal after, 50 feet? To get around that, this matrix packages the massive video signal to run over CT6 cables.
Which are just standard Ethernet cables, right?
Exactly. By using CT6, it bypasses that 50-foot limit and can blast a pristine signal up to 450 feet away. It's just leveraging standard IT infrastructure to push immense visual data.
Here's where it gets really interesting for the venue operators, though. You don't need a degree in network engineering to run this switchboard. The specs show they made the control interface incredibly accessible.
Oh yeah, totally.
A manager can just reroute the entire visual layout using the front panel buttons, a web interface, or even free iOS and Android apps on a tablet.
It completely changes how we look at physical spaces. We're taking physical, analog inputs and seamlessly converting them into easily managed network data.
Which honestly leads to a pretty wild thought to ponder. I mean, if local hardware is increasingly just acting as an on-ramp to a broader digital network, our reliance on thick physical cables and heavy writing boxes is already shrinking. So how long until the processing entirely leaves the building?
Right, like moving to the cloud.
Exactly. Will the sprawling venue of the future even need a back room full of blinking server racks, or will all of this invisible architecture just get swallowed up by cloud-based processing? It's definitely something for you to think about next time you're staring up at those screens, just marveling at the fact that there isn't a single wire in sight.